Alright folks, we're going to do all names to compounds. This is where we put it all together. Right? The rubber meets the road here. Right? So the first thing we have to do whenever we name something is we have to decide which rules to follow. So we have to decide whether it's an acid or a hydrate or an ionic compound or a covalent compound. Now this actually is a lot easier than it sounds because, for example, if I look at these, I'm just going to use a couple here. If I look at number 2 and I look at number 4, I realize they're both acids. So that's really easy. So I can tell my acids, so I have to apply my acid rules. Right? I'll notice that on number 5, I have a prefix before my second word. That tells me this is covalent. Now I'll also notice I have absolutely no hydrates on here. That means what's left must be ionic. So let me go and work out the compounds for each one of these. Right. Number 1 is ionic. So I have what would be considered to be a metal, which is arsenic, which is As. And I have sulfate, which is SO4. And when I have something that is ionic, I have to balance the charges. So sulfate's a 2- charge, and arsenic is a 3+ charge. So when I crisscross them, I have arsenic 2, sulfate 3. Alright, how about acetic acid? Well, if it's an ic acid, that means I'm looking for acetate. Right? And acetate is C2H3O2, and it's an acid, so I have to put a hydrogen in front of it. And acetate has a 1- charge, so that means I only need 1 hydrogen. How about bismuth 3 hydroxide? Well, if I have one of these things in here, that tells me it's ionic. And bismuth is Bi, and hydroxide is OH. And hydroxide always has a 1- charge, but bismuth in this case has a 3+. So when I crisscross, I need 3 hydroxide, so it's BiOH3. How about boric acid? Well, it's an ic acid, so that means I'm looking for an 8. And borate is BO3. Acids always start with H. And BO3 has a 3- charge, so that means I have to have 3 hydrogens to offset it. And finally, number 5, which is the easiest to name because it's covalent, that looks for boron, and it only has 1. And then I need chloride, so that's chlorine, and there have to be 3 of them because it's BCl3, because it's boron trichloride. That's what the tri means. All right. Well, now when I look here, you'll notice 6 and 8 both are hydrates, which means I name 6 and 8 as ionic compounds and then deal with the hydrate part of it. Number 7, you'll notice that I have a prefix, mono, which tells me it's covalent. So the first one's a hydrate. That's a hydrate. Clearly that's an acid. It ends in the word acid. And number 10 is ionic because there's no prefix and because I have this 2 sitting out here, which tells me it's ionic, because that's telling me the charge on chromium, and chromium is a metal. So for all those reasons, it's ionic. All right, so let's go and name these. Calcium is Ca, nitrate is NO3, and hydrate is 3 hydrates, which is H2O. Now calcium is a 2+ charge, nitrate is a 1-. So when I cross them, I need 2 nitrates, so I do that. Covalent compounds, the easiest one, carbon, 1 oxygen, I'm done. All right, cesium. Cesium is Cs. Carbonite. Well, carbonate is CO3. Carbonite is CO2. Cesium has a 1+ charge. Carbonite has a 2-. So when I crisscross those, I need 2 cesiums. And it's a dihydrate, so that's 2 waters. Chromic acid. That means I'm looking for chromate. And chromate is an ion that's on your ion chart, and it's CR2. It's CrO4. That's chromate. Now, has to start with H. Chromate has a 2- charge, so it has to have H2. So it's H2CrO4. How about chromium carbonate? Well, that's ionic. Chromium is Cr. Carbonate is CO3. Chromium has a 2+. Why? Because of this thing. And carbonate has a 2-, so they cancel each other out, so it's CrCO3. Alright. Calcium sulfate hexahydrate, that's going to be a hydrate, as is number 13, a hydrate. Number 12 is going to be ionic, because it has that thing inside parentheses and because it doesn't have a prefix before the second word. And number 15 is also ionic. Okay. So, let's do these. Calcium, Ca. Sulfate, SO4. Calcium is +2, sulfate's -2. They cancel each other out. Hexa means 6, 6 waters. Chromium 3 hydroxide, well, chromium is Cr. Hydroxide is OH. We're told that chromium has a 3+ charge. Hydroxide has a 1- charge. So I need to have 3 hydroxides to balance it when I do my crisscross. Cobalt 2 fluoride. Cobalt has a +2 charge. Fluorine has a -1 charge. I cross them, so that means I need COF2. And it's tetra. Tetra is 4 hydrate. I have copper 2 hydroxide. Well, copper is Cu. Hydroxide is OH. I have a +2 charge on copper. Hydroxide's a -1. So when I crisscross, I need 2 hydroxides. Cupric. Be careful about that. Cupric is a 2+ charge. Sulfate is a 2- charge, so they cancel each other out. So it's Cu. SO. Sulfate is SO4. Alright, well here I've got a nice covalent compound right here. Isn't that nice? Covalent compound, and number 18 is also covalent because I can see that prefix before the second word. 20 is covalent. Boy, this is going to be an easy one. And chromos, I'm going to have to look that one up. And cobalt 3, those are definitely both ionic. Alright, so dinitrogen. Nitrogen, dinitrogen is 2. Monoxide is 1 oxygen, so it's N2O. Chromos. So when I look up chromos, chromic is Cr3. Chromos is Cr with a +2. So that's a 2+ charge. And peroxide is O2, and it has a 2- charge. So this is going to be CrO2. That's chromos peroxide, because my charges cancel. All right, we have another dinitrogen. Right? Dinitrogen is going to be N2. And pentasulfide, sulfide is S. Penta is 5, like the pentagon, so it's N2, S5. How about cobalt 3 carbonate? Well, that means cobalt has a 3+ charge. Carbonate has a 2-. Cobalt is CO. Carbonate is CO3. But when I crisscross, I have to have 2 cobalts, and I have to have 3 carbonates. And my last one here is nitrogen, dinitrogen, trioxide. That's an O, folks. Kind of a lousy O, but it's an O nonetheless. N2O3. Okay. Hydrochloric acid. Oh yeah, what are our acid rules? Our acid rules are if it's a hydroic acid, and I'm looking for an IDE. And since this is chloride, that would be Cl. I have an H in front of it, and chlorine has a -1 charge, so I only need 1 H. While I'm on the acids, let's do number 24. Right? Hydronitric acid, which means, again, I'm looking for nitride. Nitride is on the periodic table. It's N, because it's nitrogen. And the nitrogen takes on a -3 charge, so I need 3 hydrogens to offset that. So hydronitric acid is H3N. Okay, how about cupric sulfate? Cupric sulfate. Cupric is the one that has a 2+ charge. Sulfate has a 2- charge. So this is Cu, SO4. The 2+ and 2- cancel. And we have 5 waters because it's pentahydrate. Now cuprous has a 1+ charge, and borate has a 3- charge. 3- charge. So cuprous borate is going to be Cu, BO3 for borate, and because I crisscross, I have to have Cu3, BO3. Number 25, down at the bottom, you have copper, which is Cu. Sulfite, be careful with that. That's sulfite, not sulfate, so it's SO3. And we have a 1+ charge on copper and a 2- charge on sulfate. So I crisscross them, so it has to be Cu2, SO3, and it's monohydrate, so I only have one water. All right, hydrophosphoric acid. Again, the hydroic acid means I'm looking for an ide. So phosphide would be P on the periodic table. And acids start with H. And P has a -3 charge, so this becomes H3P. How about number 28? While I'm in acid mode, sulfuric, hydrosulfuric means I'm looking for sulfide, so that's S. And acid starts with H, and because sulfur has a 2- charge, when it becomes an ion, this becomes H2S. How about nickel nitrate? Well, nickel nitrate's an ionic compound because it starts with a metal. This is nickel, Ni, and NO3 is nitrate. Nickel has a 2+ charge. Nitrate has a 1- charge. I have to crisscross them, so I end up with 2 nitrates. How about lithium nitrate trihydrate? Well, lithium is Li. Nitrate is NO3. Lithium has a +1 charge. Nitrate has a -1. So I'm good there. That all balances. And I have 3 waters. Manganese. Excellent test question. Be careful here. This is manganese. This is not magnesium. This is Mn. And it has a 3+ charge. Remember, magnesium always takes on a 2+ charge. And borate has a -3 charge. That's BO3. So the charges cancel, so I'm left with MnBO3. All right, number 31, nickel. Ni, hydroxide, OH. Nickel has a 3+ charge, hydroxide has a -1. This is ionic because it starts with a metal, so it's NiOH3. Nitrogen is starting not as a metal, it's a non-metal, so this is going to be covalent. So it's nitrogen monoxide. Notice it tells you there's 1 oxygen there. Now I have a carbonic acid, and carbonic acid tells me I'm looking for an 8. Carbonate is CO3. I put an H in front of it to make it into an acid. Carbonate has a 2- charge, so I need 2 hydrogens to offset it. I notice I have a word, a prefix in front of my second word, so this is going to be covalent, so this is an easy one. It is phosphorus, penta, chloride, so it's Cl5. All right, let's look up plumbic chloride. If I look up plumbic, that's clearly lead, but I have to figure out that it's Pb, and it's lead, and it has a 4+ charge. So plumbic has a 4+ charge, and chlorine has a -1 charge. So when I crisscross, I get PbCl4. All right, got a couple of acids in here. I've got phosphorus and phosphoric. If you remember, phosphorus means I'm looking for an ite, so I'm looking for phosphite, which is PO3. Let me jump down to the bottom one with phosphoric acid. That means I'm looking for an ATE, so that would be PO4. In both cases, they all have a -3 charge, so that means I need 3 hydrogens in both cases to offset the phosphite and the phosphate. Acids always start with H. All right, plumbous acetate. Well, there I'm definitely looking at lead again, but this is the 2+ version of lead, and the 1- version, the 1- of acetate. So it's Pb. And C2H3, O2 is acetate, but when I do my crisscross, I need to have 2 acetates. So there we go, because that's an ionic compound. 38 clearly is a hydrate, no question there, so I name it ionically. So that's sodium. Phosphate is PO4. The phosphate has a 3- charge, and sodium has a 1+ charge. So I crisscross them, so it's Na3, PO4, and tetra means 4. So it's tetrahydrate, so it's 4 waters. I notice I have a prefix before my second word. That means this has to be covalent. And of course, sulfur is not a metal, so it will be sulfur. Hexa, fluoride. Hexa means 6, so SF6. All right. Let's see. What do I notice? I notice that number 43 is covalent. I notice that 44 is an acid. I notice that 45 is covalent. So Number 41 and 42 both start with metals, so they are both ionic. In fact, 41 is a hydrate. So let's start there. Sodium is Na. Sulfate is SO4. Ooh, let's look at this next one. Sodium and sulfite, so that would be SO3. Cool, that really helps. They're very similar. A sulfate is a 2- charge, so is a sulfite. And sodium is 1+, we know that. So when we crisscross, we have to have 2 sodiums in both cases. So it's Na2SO4 and Na2SO3. The top one, however, is a hydrate. So you'll notice that it has 10 waters associated with it, because it's decahydrate. And the second one does not have any water with it at all associated with it. How about number 43? Number 43, we have sulfur. And we have oxygen, but we have 3 of them. It's sulfur trioxide, so it's SO3. Sulfuric acid, we need to know our rules for acid. An ic acid means I'm looking for an 8. So sulfate would be SO4. And I have to start with an H. And SO4 has a 2- charge. That's something you had to memorize. So it's H2SO4 for sulfuric acid. And number 45 is xenon hexafluoride. Again, we have this prefix. So it's going to be Xe, hexafluoride, so it's F, Xe, F6. All right. And the last couple that I have are sulfurous acid. Sulfurous means I'm looking for an ite. So that would be SO3. Put hydrogen in front of it because it is an acid. And the sulfite ion has a 2- charge. So I start with hydrogen, it has to be H2SO3. We have hydrate, which means the zinc sulfate has to be named as an ionic compound. Zinc is a +2, sulfate's a -2, they cancel each other out, so it's ZnSO4. And hepta means 7, and that's waters. Okay, so we are done. That was a lot. Ask me if you have questions. See you in class. Have a good one. Bye-bye.